you've seen, we can use different laser diodes for our optical fiber communication, as different laser diodes will have different wavelengths. They will have different modes of propagation in optical fiber cable. That is, when a light is guided down a fiber, that is, when light is going through a fiber, there will be a phase shift occurs at all refractive boundaries. We have seen it is passing through this core due to total internal reflection. That is, there will be a number of paths will be there. The same light will have different paths. So there will be a constructive interference and destructive interference will be there. And again, there will be different modes of propagation. So there is light may go in a zigzag manner in the case of this this optical fiber cable, and when it is hit on one wall, it will encounter total internal reflection, and sometimes there is another path that is known as without any reflection. The light may pass directly from transmitter to receiver. It will pass from transmitter to receiver without any reflection. That mode is known as the zero order mode. This is known as the zero order mode. So the zero order mode will have lesser distance. The light with light traveling in the zero order mode will travel lesser distance. Other lights will travel more distance. That is, it has to hit in one wall and again it has to hit in the another wall. So similarly, a number of modes will be there in a step index fiber as well as graded index fiber, and zero order mode is the mode having which will travel a lesser distance from the transmitter to receiver. That you can see in the next slide. Now we can see different modes of propagation in a fiber. This is a single mode fiber. This is a single mode fiber, and this is you can see the blue light. This blue line, that is, it is coming from the transmitter part to the receiver part, and it is passing in a single line, that is a straight line. It is passing in a straight line, that is having a zero mode zero propagation. So that is, you can see the same light that is transmitting in the transmitter side will received in the receiver side, and this is a graded index fiber. The transmission through a graded index fiber. You can see we are sending the same light here, and here you can see, as it is the core is having a gradual reduction in the refractive index. Similarly, the bending is also not a sharp bend. The bending is a smooth bend. The smooth bending will be a smooth bend. Again, this is a bending, again bending, and here three modes are shown. Three different propagations are shown. One is the straight line path, again a green line, again a red line. All these are the paths of the lights traveling from the transmitter side to the receiver side. And here you can see the received light will be having this characteristics, not as the same as that of the transmitter side. There will be a change in the pattern. And again, this is the step index fiber, not graded index. You can see again multiple modes are there. There will be a straight path, that is the blue. This is the blue line from transmitter to receiver. It will travel straight from transmitter to receiver. Then there is a red line. It is having a total internal reflection, and again another light having another, that is a black line having another angle of incidence, and it is taking a different path. So here you can see different the signal received will be having a different quality. All these are different modes of propagation of step index. This is the step index, and different graded index fiber, and this is a single mode fiber. So normally a single mode fiber will give, but if there is a there should for transmission in the single mode fiber, there should not be any bend in the cable or optical fiber medium. Now we can see the comparison between step index fiber and graded index fiber. In the case of step index fiber, you can see the refractive index of the core is uniform throughout the core and undergoes abrupt change at the core cladding boundary. And here in the case of graded index fiber, you can see the refractive index of the core is made to vary gradually. That is a gradual variation here, such that the maximum at the center of the core. That we have seen. Then again, another comparison is for step index fiber, there will be a diameter of the core is about 50 to 200 micrometer in the case of multi-mode fiber and 10 micrometer in the case of single mode fiber. So single mode fiber will have lesser diameter. And in the case of graded index fiber, the diameter of the core is about 50 micrometer in the case of multi-mode fiber. So in the case of single mode fiber will not be there in the case of graded index fiber. Only step index fiber will be there in the case of graded index fiber. And the other one is other advantage. The step index fiber will have a zigzag manner. That we have seen. This is a zigzag manner propagation. And again, in the graded index fiber, it will have a helical manner. That is, you can see a helical. It will be while looking from this side, you can see it as a helical manner. There is again another advantage of the step index fiber is attenuation is more for multi-mode step index fiber, but for single mode it is very lesser. And the graded index fiber, in the case of graded index fiber, it will have lesser attenuation compared to step index fiber. So these are the comparison between step index fiber and graded index fiber. So we have seen for transmission through the optical medium, we have to convert the electrical signal into light by using a laser diode. From electrical signal to light, we are using a laser diode, and in the receiver end, we are using a photodetector. A photodetector means it can be a photodiode to convert the light into electrical signal. So in the case of photodiode, normally a photodiode will work on a reverse biased manner. So in the case of photodiode, there will not be any current in the absence of the light. And normally it can be a PN junction as well as a PIN type also. PIN, P region, N region, and I stands for intrinsic area. Intrinsic, that is the depletion, similar to depletion area. So PIN. So light will hit in this I area. So there will be holes and electrons will be generated due to the incidence of light, and conduction will take place accordingly. So that is the working of a photodetector. And normally laser diode will be used for generating light from electrical signal into light. To convert from electrical to light, we will use laser diode. Normally a photodetector is the key device in the front end of an optical receiver, that is in the receiver side, and in the transmitter side we know it is a laser diode. Semiconductor photodetectors, commonly referred to as photodiodes, are predominant types of photodetectors used in the optical communication system. That is, actually we are using some kind of photosensors, that can be LDR, light dependent resistor, but normally in the optical fiber system we will use photodiodes, and it will work in the photodiodes are also similar to the structure of the laser diodes. Photodiodes are also based on PN junction. However, unlike laser diode, in the PN junction it is forward biased. That is, laser diode is forward biased. The PN junction of the photodetector is reversely biased, so that only very small reverse saturation current flows through the diode. Very lesser current will flow through the diode without the input signal, optical signal. So that is a very advantage. Normally, similar to our cutoff bias in the transistor switches, we are using lesser power in the case of a photodiode. And again you can see a photo detector. In the case of photo detector, it can be a PIN structure that we have seen. PIN stands for P type, intrinsic layer, and N type. And again another type of photodiode is avalanche photodiode. Is another type of photodiode used for the detection, and that can introduce significant photon amplification through avalanche gain. That is avalanche gain, Zener Zener breakdown. You might have heard about Zener breakdown and avalanche breakdown. So there is an avalanche breakdown will occur, and we will have very high gain in the case of a photodiode with avalanche photodiode. So these are the different types of photo detectors used in the case of this optical fiber systems. 5, 6, the next one is expression. So here we are converting the electrical signal into the light signal, and here again back from light to electrical. So optical detector. Normally optical